Hi everyone, my name is Sri, and okay, so a little background. I was a neuroscience major, and basically I was also a music producer, and had a startup that I co-founded in the music tech space, and then I basically got interested in data science, and so now I'm here. So basically I did my this project on airports and why I thought they were very important. And I learned a lot of stuff, like just researching just the background information. So I put some of the cool points up here. Basically, aviation is like the bedrock of the nation's economy because it's the only thing that transports goods and people physically, and it really leads to the global connectedness and has a profound impact on the nation's economy in the region and or throughout the whole country. So some cool stats, over 1 billion people were transported through the air in 2014 alone. And something we're going to see later, but basically the world's busiest airport is Hartsfield-Jackson Atlanta, which I thought was interesting. I think most people's common go-to is Heathrow, but that turns out that that's not the case because 88 million passengers traveled through ATL in 2009 alone. And I think there was aircraft taking off and landing every 37 seconds, so that's pretty frequently. Oh, and one more cool thing. Basically, America used to be the #1 leader in air infrastructure for a long time, but within the last 10 years, we fell to rank 30 out of 144. And the FAA, it says, has pegged the cost to the national economy at about $22 billion a year. That our drop, and they project as other nations rise, it's actually going to go up considerably to 34 billion by 2020. So okay, so the first tab, if we go, if it loads, yeah. So basically, this is showing us the connections from LAX. So this is the default connections. Again, just note, I'm not actually plotting like all the possible connections. I'm limiting it to 20 because the app just loads slower and slower for every like 20 lines. But basically, so this is connections out of LAX, and so the big circles represent international airports, and so the weight of the circles are the number of connections. So like these are all regional airports versus the bigger airports and the coastlines and throughout are just the international airports. So if we just played around with this a little bit, like so something that's interesting is if we go to kind of Salt Lake City, which is kind of in the middle, Salt Lake City and Denver, we see that the number of connections they have are decently high, 259, 220, which is interesting because these coast cities, like if we go to EWR, which actually has a large number of different airlines that actually go to it, but it doesn't have it doesn't have as much connections just because flights can connect more easily. I can't find UWR. Oh, Newark, sorry. So flights usually just come in and they connect. They go to Denver or they go to some other connecting airport. So it doesn't have as many connections, even though like we would assume that it does because it's connecting from the ocean, like from Europe. And so if we look at ATL, which is on my list, it's actually the #1. It has 346 connections, which is I thought that was really interesting. Basically, and if you go down, these two tables are actually going to filter based on what you've selected. It's going to show you by carrier. So from ATL to MIA, in 2009, this is 2009 data set, there were 6,628 carriers from American Airlines. American Airlines again, ATL to DFW, Texas, that many. So basically, this is showing you the count, and this is giving you all the different combinations from ATL to every different airport. And then over here is actually grouped it's totaled by the airline. So this is American Airlines. If you go look through this whole set, and you add up all the times, all the different places ATL is going, you'll come to this count, which is 16,475 out of ATL. And obviously, same goes for whatever airport we select. So that's the interactivity map. That's all the information I show there. And basically, so going back to what I was talking about in the overview about kind of the population and its impact on maybe the economic value, the passengers and the economic value of that. So this is a motion chart from 1970 to 2014. And like, for example, like I'm going to select United States, and I'm going to select, let's say, Sub-Saharan Africa. And if we just kind of keep an eye on, I just want you guys to notice the directions in which these two bubbles move. And this point is India. So basically, if you were to notice, pretty much there's countries that are moving upwards, and then there's countries that are moving towards horizontally. And so basically the insight that I drew from that was a lot of the countries that are moving up, if you go and look at this, are kind of developed nations. So United States, this is European Union, and a lot of these like Germany, United Kingdom, Japan, all these nations were moving upwards. And if you look closely, the size of the circle is their GDP growth over the years. So basically, like all the circles that are moving upwards, you could see you could noticeably see their GDP growing. Whereas like all the countries that are moving towards the right, like India and Sub-Saharan Africa, their populations are increasing, but the number of passengers or airline travelers they have are not really increasing noticeably. And also, their GDP is not increasing. So I think there could be a link there in terms of like what I was stating before, which is, you know, your airline, the air infrastructure that you have leads to your GDP, your kind of economic value in the global economy. And so another thing we can notice really quickly is if we go to the line chart, we can actually see the times at which there was recessions. If I do this one over 1 second. We can actually see like right here, this was the from 2000 to 2003 recession, and this was the 09 recession. And if this is European Union. So you can see that pretty much the developed nations, if you zoom in on this, are getting impacted by the global economic crisis. Like, so United States was heavily impacted, European Union was heavily impacted, Germany's, Japan. But if I zoomed in, you would see that Sub-Saharan Africa and other countries that are not as connected, their lines are pretty stable. They haven't been impacted by any of these crises. So that could be another indicator showing that, you know, they're not as connected, they're not getting, you know, they're not part of this, they're not getting the full benefit of using their airports or getting, you know, because probably their nation is not as developed, and the number of people that can actually travel is very limited, even though they do have like maybe an airport, but it's just not there yet. So yeah, and basically you can kind of subsets of, you know, if you click that, you will subset by population. So then we basically zoomed in, we kind of eliminated you know, United States and India and some other nations, so you can kind of get a zoomed in look. But again, you'll see nations going upwards and nations going towards the right, and it's clear that nations going upwards are developed and nations going towards the right are developing. So all these are, you know, developed nations. So that's the you know, that's my bubble chart analysis. The last thing I'm going to talk about is basically I took the flight counts per day for these 4 years, and basically, so this is basically technically a heat map, right? And so obviously things that we just noticed right off the bat is on Saturdays, like flights are not, there's not really that many flights comparatively on all Saturdays of the whole year. And then obviously, like, we can see holidays, like this is Thanksgiving, this is July 4th, Christmas, and there's a Memorial Day weekend. So interestingly, we'll notice like 2 days before the holidays, it's usually an increased amount of traffic. And then also, interestingly, like usually Tuesdays and Wednesdays, there's not as many flights out. So, and basically, like, you can effectively just select any date on the calendar, like say August 8th or August 7th, my birthday. And basically, you'll be able to see on that date, I subset it by 20, but on that date, the unique carriers and the amount of airplanes that went out. So, you know, on August 7th, 2007, WN, which I think is Southwest, has 3,000 airlines flying out. American Airlines has 1,700, about 1,700 airlines. United Airlines, So basically, you can just select any date on this calendar and see the top 20 airlines out of that day. So, and then, yeah. So basically, and then if you look at my appendix, you can kind of go through and see the different data sets that I used. And, yeah, that's pretty much it. So, do you guys have any questions?
So
yeah. Huh?
What are the deadlines?
Which ones?
The ones with the deadlines?
Oh, these lines?
Yeah.
Each cell is a single day of the year. So yeah, so like this is September 3rd, September 4th, September 5th. It's just they're in cells. Yeah. So yeah, go ahead. Huh? Yeah, so if you just log on to the app I have in the appendix, I'll show you after. Basically, you can just log on to the app, and then if you go in the appendix, I have listed all the data. You can click and go to what I used. So this website has you can download by by year, by month, and then somewhere it's by day. You can get it also. Or maybe I didn't get the per day from here. But yeah, so all my data sets are listed right here for you.
Any special processing?
Oh yeah. Oh yeah. I mean, so basically, like I have a blog post also, and you can go read. And I have, yeah. It goes through all. There's so much for the bubble chart. Like I combined data sets from the World Bank, the population, passenger count, and GDP. And so interestingly, you'll notice that China is not on here because China didn't provide the passenger count. They provided the population and the GDP, but they didn't provide the passenger count. So when I joined it, I lost like some countries, including China. But I had to do some manipulation for that. Yeah.
How is that air infrastructure rank defined?
Which one? This one?
Air infrastructure rank. How is that defined?
On this slide, I didn't really define an air infrastructure. This number is just the connections.
Right. So your point in the first slide is that the U.S. has really dropped.
Yeah.
In air infrastructure.
Right.
Rank.
Right.
What is that?
That was just.
How do you measure that? How do you measure that? Where did you get that?
Oh, that was just.
Fine.
Yeah, that was just like when I going to do this background slide. I just found like some interesting points to put up, and basically like that was just one of the points that I found. It was reported by the FAA. I didn't do any research on that. I just pulled it up.
You don't know how it's defined.
No, okay. I mean it's basically just defined by the total like the revenue from airports. Like I'm pretty sure that that's what it's defined by. So the number of passengers and the revenue per airports in the United States versus Europe and France and a lot of countries. I mean, but you can go and look it up. It's
big drop.
Yeah, in 10 years. I mean, that's because of global economy. It's because the European Union picked up considerably. I mean, you can notice that in the bubble chart. If you go here, so you'll see that, like, European Union, which is equal GDP-wise, it's equal to the United States. It's picked up just at the same rate as America, and you have to understand that you have to consider like all these other nations that are now eating into the American infrastructure. Before we were the leaders, we were one of the only countries with as much connectedness as we had. But then as all the other countries developed, they ate into our infrastructure, and we're no longer number one. Yeah. That's a good question. I mean, yeah. I mean, I guess it's only cheap in the around this area, and then it was expensive around this area. So I'm not sure. I would have to look into that. Yeah, that's a good question.
Is it getting cheaper to travel by that? 20 years relative to
I didn't look into that question, but yeah, I didn't look into that. Yep.
What were some of the tools or libraries you used?
Yeah, so a bunch of different libraries as well. So I mean, I listed the libraries here. So again, if you just go to it. So obviously the big ones are Leaflet, Google Viz, rcurl, stringr, reshape. I use those pretty much in every kind of manipulation. Oh, one thing I forgot to point out. So this kind of weird web-like structure is just the Voronoi tessellations. So it's kind of plotting the areas in between the closest airport. So like with one nearest neighbor. Another thing I noticed, I mean, which is kind of obvious, is in the Midwest, the polygons are much larger than in any of the coasts. You know, it's pretty obvious, but that's because there's the distance between every other airport in every direction is far. So if you kind of click on any of the polygons, you'll see the name of the airport in that polygon. So.
Do you use rcode? Are you pulling data out of
rcode is I designed everything. I mean, I coded everything in R.
rcode?
Oh yeah. So basically, there's one specific thing I need to do for string manipulation. I'm pretty sure in manipulating the data, just to I think it was when I was reading the data in.
So you know that's the same as anything else?
No. Yeah.
How do you store that? Just like
Yeah, they're in I'm downloading CSVs, and they're in CSV format, loaded in as a data frame. They're all data frames, yeah, except for a few things that are in vector format, like the polygon is shifting the state lines, stuff like that, is not in a data frame. It's in list. But everything else, like almost everything on this thing that I use, they're all in data frames. And they're all being loaded for this. That's why this app is kind of slow, because I'm loading multiple different, like this is using 3 different data sets, and then this itself is using a couple data sets, and then the calendar is using, actually the calendar is the most intensive because I'm loading the count per day for every carrier. But it's all in one, this is in one data set. I merged like different things into one.